Good morning to everyone. Myself is Devi, Assistant Professor, Department of Artificial Intelligence and Data Science. I am going to teach the subject structures using C++. Today we are going to discuss about the use case in biomedical imaging, power grid modeling, circuit routing. Structures are essential in complex application where large amount of data needs to be stored, accessed, processed efficiently. The following are some of the key domains. First, we will say about the biomedical imaging. Biomedical imaging includes the technology like MRI, CT scans, ultrasounds, which produce large amount of digital image data. Efficiency processing and storage of this data require appropriate data structure. The various data structures used in array, linked list, tree, graph. See how it is used in array. The images are stored in the form of 2D or 3D array. Each element represents pixel intensity or color value. Linked list. It is used in the case of dynamic memory allocation, and tree is used in the case of image compression or regional segmentation, and graph is used in the case of image segmentation where pixels or nodes on edges are represent similar between pixels. In use cases, power grid modeling. The power grid are a complex network which generates substantial load connection through transition lines. Modeling these system efficiency is critical for simulation optimization and fault detections. The data structure used are graph, matrix, and queue. Graph. The nodes are represented as generators, substituent consumer, and the edges are the transition lines, and it supports power flow calculation and network analysis. In the case of matrices, it stores connection between the nodes in this structured way. It enables matrix-based simulations of grid behavior. In the case of queue, a priority queue is used in the case of load balancing algorithm and fault handling. Queue help in dispatching power efficiency. The last one is circuit routing. Here, the circuit routing involves connecting components on the chips or PCB using wires or traces. These require efficient path finding and layout optimization. The data structure used are graph, tree, grid, stack, or queue. Similar to the previous one, here the node is the circuit put and edge is the possible wiring path used for circuit algorithm like maze routing. And tree, in the case of tree, minimum spanning tree is used for signal routing with minimum wire length. In the case of array, it represents the layout of space of the chip or board. Each cell indicates free or occupied space. In the case of stagger queue, which is used in the case of root pathing during exploitations, that is BFS or DFS staff cell is used. In case of biomedical imaging, data structure used are array, linked list, and tree, and it is used in the case of store image compression, segmentation, and rendering. In the case of power grid modeling, the data structure uses graph, matrices, and queue. The main benefit is model network, simulation, power flow, optimization, dispatch. And the third one is circuit routing. In that case, the data structure used is graph, tree, array, stack, or queue data structure. It is used in the case of optimization PCB layout connection component efficiently. All about the use case in the biomedical imaging, power grid modeling, circuit routing. We will see about the next topic in the next section. Thank you.